Welcome back. Today we will see few problems on a flow through pipe. Okay, so we have finished the theory part of a flow through pipe. Now we will solve few problems on a flow through pipes. Let's begin. This is the first problem. Now this problem is the basic fundamental problem or to calculate the major loss. How to calculate the major loss? Yes. So what is the problem statement? Yes, it says that a pipe is used for the energy transmission, okay, whose length and the diameter. First length is given, then diameter is given. Length is a 80 meter and diameter is a 50 centimeter respectively. The flow rate is a 105 liter per second. Calculate the frictional loss, and while calculating this frictional loss, neglect the minor losses. Okay, take F as a 0.03. So from this problem statement we can write down the given data. Okay, what is the given data? Length is given, then diameter is given. Always remember, yes, convert all the non-SI quantity into a SI quantity. Yes, diameter D is given as a 50 centimeter. Okay, so convert that in terms of a SI unit. Okay, now next one is the discharge is given. Flow rate means discharge, its value is given as a 105 liter per second. Yes, now liter per second is not SI unit. Okay, so we need to calculate in terms of a SI unit. SI unit for the discharge is a meter cube per second. Yes, SI unit for the discharge is a meter cube per second. And we know the relation between the liter. Yes, 1 liter is equal to 10 raised to minus 3 meter cube. Yes, 1 liter is equal to 10 raised to minus 3 meter cube. Okay. So this conversion, yes, if we divide 10 raised to minus 3 means divided by the 1000. So we will get in a SI unit, the discharge Q is equal to 0.105 meter cube per second. Okay, also the friction coefficient of friction is given as a F is equal to 0.03. Now we want to calculate the frictional loss. Okay, we want to calculate the frictional loss. So we are having only one formula to calculate the frictional loss for this case. Yes, that is Darcy's Weisbach formula. Okay, so now we are having a formula. Yes, HF is equal to 4FLV square divided by 2GD. Yes, we want to calculate HF. 4 is constant. F is given here. Yes, 0.03. Then length is also given. Then velocity, it is not given. Diameter is given. 2 is known. Yes, G is a constant. Yes, we are unaware about the velocity. So we can calculate the velocity. Yes, velocity. For the calculation of velocity, we are having a continuity equation. Continuity equation says that Q is equal to A into V. Discharge is equal to product of a area into velocity. So area can be calculated by the formula pi by 4 into d square into V. Okay, so now area is this much and multiplied by the V. So if we rearrange, V can be written as 4 goes in this side. Okay, so 4Q divided by this pi d square. So either you can first calculate the velocity. Now here in this formula, Q is given. Yes, Q is given. This much is, this value is given. Then pi is known, 4 is known, d value is also given. So you can calculate the velocity and you can put in this formula now. Now velocity is also known. Yes, and you can put in the formula and you will get final frictional loss, and that is the need of this problem. So we will solve this problem. Now there are two ways. Either first calculate the velocity separately, or instead of velocity you can put this formula as it is. Okay, so there are two ways. Okay, so we will prefer one. So this is the preferred one is the putting the value of a velocity v as a 4q divided by pi d square. Okay, so here remember, here velocity square is there, so whatever the term is there, yes, you need to square, have a square of that term. Okay, so we are putting this value 4q divided by pi d square. All other terms are as it is, 4fl as it is. Instead of velocity we are putting this, and 2gd, yes, d into 2g as it is. Okay, so ultimately this is the alternative formula for the calculation of a friction loss. Okay, so you can remember this formula also. This is also exactly correct formula, because we have done only a mathematical operation on the formula which is given by the Darcy's Weisbach. Okay, so now we can put the value. Okay, so 32. Now here the calculation is done, and final calculation says 32 FLQ square divided by pi square into d raised to 5 multiplied by the g. This is the formula for the friction loss. Just put all the value. 32 as it is. It is a constant. F value is known, 0.03, put here. Then L value is 80, put here. Okay. Then Q value 0.105, its square. Okay. So put here in a SI unit only. Okay. Then pi square, it is a constant, yes, 3.14, its square is there. Then in the denominator itself, 0.5 raised to 5, yes, this value is there, and 9.81, this is the g value. If you do this calculation, you will get the friction head loss, yes, as a 0.27985 meter. Yes, do this calculation, check whether this calculation is correct or not. Okay, so this was the first problem on the unit number